Japan is developing a next-generation fighter that will control the battlefield from the air, not just operate within it. Designed to work with coordinated drone formations, this aircraft will allow a single pilot to direct autonomous systems conducting reconnaissance, electronic warfare, and strike missions ahead of the manned jet. The program, part of the Global Combat Air Program, represents a major shift toward networked air combat, one that regional powers are monitoring closely. So what exactly is Japan building, and why has it raised concerns about the future balance of air power in the Pacific? Join us as we examine how Japan's next-generation fighter is commanding combat drones and why it is drawing serious attention. For most of the post-war era, Japan operated under a constitutional framework that severely restricted its military ambitions. It could defend itself but not project power, export weapons, or develop an indigenous fighter without bowing to American technology controls that kept its own aerospace industry perpetually dependent on Washington's approval. That Japan is gone, and the country that replaced it is spending money, building alliances, and developing weapons at a pace that Beijing is watching with genuine alarm. Japan raised its military budget to 8.4 trillion yen, roughly $57.8 billion for fiscal year 2025, with an additional 1.5 trillion yen on related spending, bringing total defense expenditure to approximately 1.8% of GDP and moving the country toward its stated target of 2% by 2027. To put that in context, Japan's defense budget 20 years ago was legally capped at 1% of GDP. The number has nearly doubled, and the things Japan is spending that money on are the things that make China's military planners sit up very straight. At the center of all of it is GCAP, the Global Combat Air Program, a sixth-generation fighter jet being developed jointly by Japan, the United Kingdom, and Italy, targeted for operational service in 2035, and designed around a concept of warfare that goes well beyond anything currently flying in the Indo-Pacific. GCAP brings together Mitsubishi Heavy Industries from Japan, BAE Systems from the UK, and Leonardo from Italy in a program that incorporates advanced stealth, electronic warfare, artificial intelligence, and loyal wingman drones. The schedule calls for a technology demonstrator flight around 2027 and entry into service around 2035. The phrase loyal wingman drones deserves unpacking because it is the detail that most distinguishes this aircraft from anything in the current generation of fighters and the detail that most concerns China's military planners. Traditional air combat involves one pilot in one aircraft, supported by other pilots in other aircraft. A sixth-generation platform like GCAP operates differently. UK Ministry of Defence representatives have confirmed that the GCAP will carry sufficient computing power to control a system of systems, including low-cost autonomous drones, while operating deep inside hostile territory where connections to traditional support assets may be restricted, all while remaining survivable. Think about what that means in practice. A single GCAP pilot flies toward a defended zone. Around the aircraft, a swarm of autonomous drones fans out. Some of them carry radar jamming systems that blind the enemy's sensors. Some carry weapons that can be fired independently. Some fly ahead to draw out enemy missiles and absorb hits, deliberately expendable decoys that force the defender to waste interceptors on unmanned targets. Meanwhile, the manned GCAP sits behind the swarm, invisible in its stealth configuration, collecting data from every drone simultaneously, synthesizing the entire battlespace picture in real time, and directing the swarm's actions like a quarterback calling plays. Japan's Ministry of Defense published an evaluation report in August 2025 detailing the rationale for developing collaborative UAVs capable of manned-unmanned teaming with GCAP. The document highlighted two urgent priorities: the need to account for potential development delays to meet the 2035 deployment target, and the need for Japan to rapidly build indigenous UAV capabilities to ensure it could meaningfully contribute to any joint research and development projects in the collaborative combat aircraft field. Japan is not waiting for GCAP to be finished before it starts developing the drones that will fly with it. The two programs are running in parallel. Japan's fiscal 2026 budget allocated 4.9 billion yen, approximately $32.3 million, specifically for the collaborative UAV project to commence its conceptual design phase. Japan also announced that the Japan Air Self-Defense Force would participate in observation and training related to Boeing Australia's MQ-28 Ghostbat, a wingman being developed for the Royal Australian Air Force. Japan is not just designing its own loyal wingman, it is studying someone else's loyal wingman simultaneously, learning from the operational experience Australia is developing with the Ghostbat, to make sure its own system benefits from every lesson already being learned in the field. Now here is where the sensor architecture of GCAP becomes the real story, because the drone control capability is only as good as the information system that makes it possible. On current 4th and 5th generation fighters, sensors still work largely in a stovepipe capacity. They share information into a common hub, but do not actively cross-check or prioritize data among themselves. On GCAP, a multifunction processor will rapidly process all incoming sensor data before it ever reaches the cockpit, synthesizing radar, electronic warfare, infrared search and track, and other inputs into a single coherent picture before the pilot sees it. The difference between a stovepipe sensor system and a fused one sounds technical, but its operational consequence is enormous. In a 5th generation fighter, the pilot receives raw feeds from multiple sensors and must mentally integrate them into a situational picture under extreme time pressure, in a cockpit moving at supersonic speed while simultaneously flying the aircraft and managing weapons employment. In GCAP, that integration happens below the level of human awareness. The pilot receives a fused picture that has already been assembled, cross-checked, and prioritized by a machine. The cognitive load drops, the decision speed increases, and the pilot's mental bandwidth, freed from the work of synthesizing conflicting sensor feeds, can be spent on what humans still do better than machines: judgment, tactics, and command. The future aircraft's radar is intended to deliver 10,000 times more data than current systems. Leonardo UK's ISANKE and ICS architecture, integrated sensing and non-kinetic effects, plus integrated communication systems, will allow GCAP to sense first, fuse faster, share securely, and survive inside dense electronic warfare environments where detection, jamming, deception, and targeting happen almost simultaneously. 10,000 times more data. That number requires a moment to sit with. The F-35 is the most advanced fighter currently in operational service anywhere in the world, and GCAP's radar is being designed to generate 10,000 times more information than the sensors on aircraft of that generation. The processing required to make that data useful, rather than simply overwhelming, is what the multifunction processor is being built to handle. British defense official Group Captain Bill Sanders explicitly stated that GCAP must be able to work with any number of different loyal wingman drone types, not just one national design, because commanders in a real conflict need maximum flexibility to use whatever platforms are available. The fighter's weapons bay is being designed with the same philosophy, capable of accepting any weapon used by the partner nations, by NATO, and by the United States. That weapons bay flexibility is not just a logistics convenience, but also a strategic statement. In any actual conflict, initial strikes are conducted with the most capable and expensive precision weapons. As those stockpiles run down under attrition, the ability to switch to cheaper, more available munitions without sacrificing effectiveness becomes critical. GCAP is being designed from the beginning to accommodate that transition, to start a war with the best weapons and finish it with whatever is available, rather than becoming combat ineffective the moment its preferred munition runs short. Program officials have confirmed that GCAP is expected to carry roughly double the weapon payload of an F-35A and may have sufficient range to cross the Atlantic Ocean on internal fuel without refueling, unlike the Eurofighter Typhoon, which requires 3 or 4 refueling stops for the same journey. Double the payload of an F-35, intercontinental range on internal fuel, a radar generating 10,000 times more data, autonomous drone command capability deep inside hostile territory. These are not marginal improvements on existing technology. They represent a genuinely different conception of what a fighter aircraft is and what it does. Now set all of that against the backdrop of what is happening between China and Japan right now, and the strategic weight of GCAP becomes much clearer. Relations between China and Japan entered a state of diplomatic crisis in November 2025 after Japanese Prime Minister Sanae Takaichi stated in Parliament that a Chinese attack on Taiwan could potentially constitute an existential crisis for Japan, allowing Japan to take military action in collective self-defense. China's consul general in Osaka made threatening statements in response, triggering a significant diplomatic row between the two countries. This was not a slip of the tongue. It was a deliberate signal from Tokyo that Japan no longer views its security as separate from Taiwan's. And China understood that signal precisely as intended, which is why the reaction was so sharp. China is not standing still while Japan builds. Beijing has its own sixth-generation programs underway. The race is real, the stakes are direct, and both sides know it. What makes GCAP particularly alarming for Chinese planners is not just the aircraft's capabilities in isolation. It is the coalition architecture building around it. On April 1st, 2026, the UK, Italy, and Japan awarded Edgewing the trinational industrial joint venture formed by BAE Systems, Leonardo, and Japan Aircraft Industrial Enhancement Company Limited, a £686 million contract, formally designating it as GCAP's Unified Design and Engineering Authority, marking the program's transition from a politically coordinated national effort into a fully integrated international acquisition program with a single design authority. This is the moment where GCAP stopped being three countries talking about building a fighter together and became one program with one design authority, one industrial chain, and one objective. Japan is expected to be GCAP's primary operator. The technology transfer involved in the program gives Japan access to advanced aerospace capabilities that it could not develop alone in the necessary timeframe, while also giving Japan stronger negotiating power and greater leadership influence over future defense exports. This is a country that was legally prohibited from exporting weapons for decades. Now it is positioning itself as a leading exporter of one of the most advanced combat aircraft ever designed. Japan has already fast-tracked a revision of its export restriction policies specifically to accommodate GCAP exports to allied nations, opening the door for countries like Australia and India to eventually acquire the platform. If Australia and India become GCAP operators, the coalition of nations flying this aircraft and the loyal wingman drones it commands would span from Europe across the Indian Ocean to the Pacific, surrounding China's sphere of influence with a network of interoperable, sensor-fused, drone-commanding sixth-generation fighters. That is not a theoretical future concern. It is the strategic architecture Japan, the UK, and Italy are deliberately constructing right now, and China can see every piece of it taking shape. Analysis from the Royal United Services Institute has emphasized that sixth-generation aircraft are essential specifically for the Indo-Pacific theater because of the vast operational distances involved and the vulnerability of aerial refueling tankers to Chinese long-range missiles. Such aircraft need to operate securely beyond missile threats with sufficient internal fuel and weapons to conduct extended missions without dependence on vulnerable support assets. This is a direct response to one of China's core military strategies. Beijing has spent 2 decades building missiles specifically designed to threaten the tanker aircraft and air bases that American and Allied fighters depend on. GCAP's intercontinental fuel range is not an incidental capability. It is a deliberate counter to that strategy, a fighter that does not need a tanker to reach its target and therefore cannot be denied access to the fight by destroying the tanker fleet. The most advanced heavy-lift helicopter ever built is about to be transported. Japan's brand new $500 million CH-53 is being loaded into the massive C-5 for air delivery by the United States. But moving such a huge machine is not easy. Crews must carefully remove parts, secure every section, and ensure nothing goes wrong. One mistake could cause serious damage. How does this giant helicopter fit inside the aircraft? What makes this mission so difficult? Join us as we explore how the U.S. is loading Japan's brand new $500 million CH-53 helicopters into massive C-5 for air delivery. The United States has built a helicopter that is stronger and more advanced than any heavy-lift helicopter before it. The CH-53 is one of the latest helicopters made for carrying large and heavy loads over long distances. It is designed to lift more weight, fly in worse conditions, and make work easier for the pilots. This helicopter is completely different from the older models, and it comes with new technology that makes it the best. For many years, helicopters have been used to move supplies, transport troops, and carry weapons into battle. But as time passed, the need for a stronger and smarter helicopter became clear. The older models had been in use for many years, but it was time for something different, and then the CH-53 was built. This helicopter can fly, travel farther, and take off in places where other helicopters would struggle. It can operate in hot deserts, cold mountains, and on ships in rough waters, but not for a long period of time. This helicopter was built to handle missions that no other heavy-lift helicopter could do before. The United States is not the only country that needs a helicopter like this. Japan has also decided to use this powerful machine. With the CH-53, Japan will be able to move troops and equipment quickly, respond to emergencies faster, and carry out military missions with better efficiency. This is important because the areas where Japan operates are full of islands and rough places, making helicopters the best way to transport heavy loads. The pilots who fly this helicopter have better systems to help them navigate, land, and take off in difficult conditions. The engines are stronger, the controls are better, and the entire helicopter is made to be as reliable as possible. In the past, helicopters had to be careful about how far they traveled with a full load. But this helicopter is designed to carry the weight of armored vehicles, large supplies, and important equipment. But the engineers noticed that this helicopter could do better, and it was decided to be upgraded. $500 million is said to be used to upgrade the old version of CH-53 helicopter. Every part of this helicopter has been upgraded, and it starts with what gives it power, which is the engine. The engines inside the helicopter are the strongest ever put into a heavy helicopter. They give it the ability to carry more weight than usual, fly higher than expected, and go farther without struggling a bit. The older version had to work harder to carry heavy loads. They used engines that needed more fuel and could not always handle the demands of modern missions. The brand new helicopter has new engines that produce more power while using fuel in a better way. This means that it can lift heavier loads without slowing down. It can also fly for a longer time before needing to refuel. But the engine is not only known for its power because it can do more than that. The engine can help the helicopter perform better in tough conditions. While the older version of this helicopter had issues with places like the deserts, mountains, and oceans, this one does not have this problem. The engines are designed to handle hot temperatures, thin air, and long-distance flights without losing power. Another big improvement is how this helicopter controls itself in the air. Pilots no longer have to fight to keep the helicopter steady. The brand new CH-53 comes with new fly-by-wire controls. This means that computers help the pilot control the helicopter. The system makes sure that the helicopter stays balanced, even in rough weather. It also helps the pilot make better movements, making flying easier and smoother. Fly-by-wire systems are used in modern fighter jets, but heavy helicopters like this have never had them before. The new CH-53 is the first to use this advanced technology. The older version needed pilots to make constant adjustments to keep the helicopter stable. This new system does that work automatically. The pilot can now focus on flying the mission instead of making small corrections every time. Inside the cockpit, everything is different compared to the old versions. The screens are bigger, the buttons are easier to use, and the information is clearer. In the older versions, the pilots had to read many different gauges and dials to know what was happening with the helicopter. But the new CH-53 gives them everything they need on digital screens. This makes it easier to understand fuel levels, altitude, speed, and other important details. The new cockpit also has better night vision and navigation systems. Older helicopters struggled to fly at night or in bad weather. Pilots had to rely on what they could see with their own eyes. This advanced helicopter has cameras, sensors, and radar that help pilots see in the dark through fog and in storms. No matter what the weather is like, this helicopter can complete its mission. Communication is another important area where this helicopter stands out. In the previous versions, talking to other aircraft or ground troops was not always easy. But this new version has improved radios and communication systems that allow it to stay in contact with multiple units at the same time. This is important in military operations where helicopters, ground forces, and command centers need to work together. This helicopter also has better self-defense systems. In battle, helicopters are often targeted by enemy missiles and weapons. This helicopter is designed to protect itself. It has systems that detect incoming threats and release flares or other countermeasures to avoid being hit. Other helicopters did not have strong defense systems, but this advanced helicopter was built to survive in dangerous areas. The materials used to build this helicopter are also better. It is made from stronger, lighter materials that allow it to carry more weight without being too heavy. Normally, helicopters have to choose between being tough and being light, but this upgraded helicopter does not have to make that choice. It is strong enough to handle rough landings and heavy loads, but light enough to fly efficiently. Another important upgrade is how this helicopter handles damage. In war zones, helicopters often take hits from enemy fire to the point that small damage could cause serious problems. The new CH-53 is built to keep flying even if some parts are damaged. It has backup systems that allow it to complete its mission and return safely. Maintenance is also easier with this helicopter. Other helicopters took a long time to replace because they had complicated systems that required a lot of work. The brand new helicopter is designed to be easier to fix. The parts are made in a way that allows them to be replaced quickly. The maintenance crew can get the helicopter ready for its next mission faster than ever before. The way this helicopter handles fuel is also improved. Older ones needed refueling more often, which made missions take longer. The new CH-53 can carry more fuel and use it better. It also has the ability to refuel in the air, meaning it can stay in flight for a long time without having to land. Everything about this helicopter is designed for modern missions. It is stronger, faster, and more advanced than any heavy-lift helicopter. It has better engines, better controls, better protection, and better technology inside. Every part of it is made to help the pilots do their job more easily and safely. The brand new CH-53 is a helicopter made for the future. It is made to handle the needs of modern missions, from military operations to rescue missions. This helicopter is a completely new way of thinking about how heavy-lift helicopters should work. It is the strongest, smartest, and most reliable helicopter ever made. And now it is ready to be used in ways that will change how missions are carried out across the world. This is the next generation of heavy-lift helicopters, and it is built to stay ahead for many years to come. Now, this brand new $500 million CH-53 is about to be loaded inside the massive C-5 for air delivery. But one important thing to note is that moving heavy equipment across the world is not easy to do. Ships take too long and smaller aircraft cannot carry enough. Some places have no roads, making ground transport impossible. The military needed a way to move the biggest and heaviest machines fast. That is where the C-5 comes in. It is the largest transport aircraft used by the United States military. It is built to carry tanks, helicopters, and supplies across long distances without stopping. This aircraft is a machine designed for heavy lifting. It has a massive cargo hold that can fit the largest military equipment. It can carry an entire helicopter, armored vehicles, and even multiple trucks at the same time. No other aircraft in the United States military can carry as much as this one. Loading this aircraft is different from loading other planes. It has a unique design that allows cargo to enter from both the front and the back. This makes loading and unloading faster. Other transport planes have only one cargo door, meaning everything must be moved in and out from the same side. The C-5 does not face this type of challenge. It allows crews to load from the front and unload from the back, saving time during missions. The size of this plane allows it to carry more supplies in a single trip. Instead of making multiple flights, it can complete the mission at once. This is important in military operations where time is critical. Troops need their equipment fast, and the C-5 delivers without delay. The engines on this plane are stronger than those on older versions of the aircraft. They allow it to take off with heavier loads and fly longer distances without stopping. Back then, transport planes had to land for refueling on long flights. This aircraft reduces the need for stops, making global transport easier. The aircraft is also built for rough conditions. It can take off and land on short runways, allowing it to reach remote bases. It can operate in extreme weather, flying through storms and harsh environments without trouble. One of the biggest challenges in military transport is moving helicopters. Helicopters are large, heavy, and difficult to transport by SIR. The C-5 is one of the few aircraft that can carry helicopters. Most transport planes require helicopters to be taken apart before they can be loaded. This aircraft's cargo hold is big enough to fit helicopters without removing parts of it so that it could fit in. This makes it easier to move helicopters across long distances and have them ready to fly as soon as they arrive. This transport aircraft also has an advanced loading system. In other transport planes, crews had to rely on external equipment to move cargo inside, but this plane has built-in ramps and a winch system that allows it to pull heavy loads into the aircraft. This means that helicopters, tanks, and trucks can be loaded without the need for extra machines. The process is faster, more efficient, and reduces the number of people needed to complete the job. The crew inside this transport aircraft is small, but they are highly trained. The aircraft is operated by a few pilots and loadmasters who are responsible for ensuring everything is packed and secured correctly. Loadmasters must know how to balance the cargo to prevent weight issues during flight. Every item inside the aircraft is secured to prevent movement. If cargo is not locked in place, it can shift during flight and cause problems. Another feature that makes C-5 special is that it has the ability to refuel in the air. This means that it does not have to land to get more fuel. This allows it to stay in the air longer and transport supplies over greater distances without stopping. This feature is especially important during military missions where time is critical. The C-5 is also used for another mission. When there is war, roads are often destroyed and ships take too long to arrive. This transport plane can carry emergency supplies, food, medical equipment, and rescue vehicles to areas that need help fast. It has played a major role in natural disasters by delivering important things needed to people affected by hurricanes, earthquakes, and other natural disasters. The size and strength of this plane make it one of the most important aircraft in military transport. Without it, moving large equipment would take much longer. It allows the military to respond to emergencies faster, supply troops more efficiently, and deliver heavy equipment anywhere in the world. The C-5 should not be seen as an ordinary transport plane, but it should be seen as a machine built for speed, power, and efficiency. It is designed to handle the toughest missions, carrying the heaviest loads across the longest distances. Whether moving helicopters, tanks, or emergency supplies, the C-5 is built to get the job done. Meanwhile, moving a CH-53 is not simple. It is one of the biggest helicopters in the world. It is wide, tall, and built to carry heavy loads. Now that it needs to be transported across long distance to another country, it cannot always fly by itself. This is why the C-5 is needed. This massive aircraft is one of the only planes big enough to carry the CH-53. But fitting such a huge helicopter inside a transport aircraft is not easy. It takes careful planning, skilled crews, and precise movements to make it work. The first step in loading this huge helicopter into the massive transport aircraft is preparation. The helicopter is too tall to fit inside the cargo hold as it is. To make it small enough, some parts must be removed. The rotor blades, which are long and extend outward, are taken off. The tail section is also removed. These parts are carefully placed on transport racks so they can be reattached later. Even with these parts removed, the helicopter is still a massive piece of equipment. Once the helicopter is prepared, it is moved closer to the aircraft. This process must be done carefully. The plane sits low to the ground when loading, using a special system to lower its nose. This helps create a straight path for cargo to enter. A team of loadmasters, ground crew, and engineers work together to make sure everything is lined up correctly. If the helicopter is not perfectly positioned, it will not fit inside. The next step is moving the helicopter into the aircraft. This is not a simple task. The helicopter is pulled inside using a powerful winch system. This system slowly moves the helicopter forward, making sure that it does not hit the sides or the ceiling of the cargo hold. The clearance is small, and there is not much space between the helicopter and the walls of the aircraft. Every movement must be controlled with precision. As the helicopter moves inside, the loadmasters keep checking the position. They look at every angle, making sure it is aligned properly. If anything is even slightly off, they stop and make adjustments. They also watch for any parts of the helicopter that could get caught on the edges of the cargo bay. The process is slow, but it has to be done correctly. Once the CH-53 is fully inside, it must be secured. The helicopter cannot just sit freely in the cargo hold. If it moves during flight, there will be serious issues. Strong straps and chains are used to lock it in place. These are attached to special anchor points in the floor of the C-5. The loadmasters check every connection twice in order to make sure that the helicopter is completely secured. Though the C-5 is designed to carry heavy loads, but balance is really important. If the weight is not distributed correctly, the aircraft will not fly properly. The loadmasters calculate the weight of the helicopter and adjust the placement of other cargo if needed. Everything inside must be arranged in order to keep the aircraft stable during flight. Once the helicopter is secured, the crew prepares for the takeoff. The powerful engines of the aircraft are started and it begins to walk down the runway. The pilots carefully lift off, making sure that the aircraft handles properly with the heavy load inside. During flight, the crew continues to monitor the cargo. They check the straps and make sure that nothing is shifted, and also confirm that everything remains secure. When the aircraft arrives at its destination, unloading the CH-53 is just as important as loading it. The process is done in reverse. The straps are removed, and the winch system carefully pulls the helicopter out of the cargo hold. Ground crews are ready to reattach the rotor blades and tail section so the helicopter can fly again. Transporting a CH-53 and a C-5 is not just about moving a helicopter. It is about precision, skill, and teamwork. The entire process must be done perfectly to make sure the helicopter arrives safely and is ready for action. Whether for military missions, disaster relief, or strategic deployments, the ability to transport such a large helicopter quickly is a major advantage. The C-5 and CH-53 together create a powerful combination. One is built for transport, and the other is built for heavy lifting. When they work together, they make sure that military forces can move fast, respond quickly, and complete their missions wherever they are needed. With tensions between China and the United States growing more intense, America's allies, especially Japan, have been left with no choice but to find ways to defend themselves against future threats. Japan has gone the extra mile, developing aircraft unlike anything ever seen in aerial warfare. Armed with technology so advanced that even European nations are eager to collaborate, Japan is finally stepping up to claim its place among the world's military powers. Could this be the beginning of Japan's military resurgence? What can this next-generation fighter truly do? Join us as we reveal the groundbreaking details of the new bombers Japan has just added to its arsenal. After the Second World War, Japan became very cautious about rebuilding its military, especially its air force, which now appears outdated compared to that of other countries. The memories of Hiroshima and Nagasaki still remind everyone of how terrible war can be. Japan's new constitution, drafted with the help of the United States after the war, took a firm stand against war. In Article 9, Japan relinquished its right to wage war or maintain military forces for aggression, limiting its forces to self-defense purposes only. Japan also made a deal with the United States for protection. American troops, including air forces, stayed in Japan to defend the country. This allowed Japan to rebuild its cities, businesses, and industries without undue concern for war. But as time went on, growing problems with China and fears about North Korea's missiles made Japan change its thinking. China's rapid rise in both economic and military strength began to appear more unfriendly toward Japan. Because Japan supported Taiwan and worked closely with the United States, China hit back with trade bans and boycotts. Behind the scenes, China also used cyber attacks and spying. They broke into Japan's government and business systems, attempting to steal sensitive secrets related to defense and technology. China sent more ships and planes close to Japan's borders. They started doing regular live-fire drills and even launched ballistic missiles near Taiwan, one of Japan's close partners. With danger rising, Japan recognized the need to enhance its air force, rather than relying solely on others, especially since China and Russia are now introducing more advanced fighter jets. In a big move, Japan's leaders have recently agreed on new rules that would enable the country to respond more effectively to threats. Former Prime Minister Fumio Kishida stated that With missiles becoming faster and more deadly around the world, Japan must strengthen its defense to deter future attacks. This decision also followed the United States' urging of Japan to assume a greater role in containing China's expanding military. This new plan will increase its defense budget to 2% of its economy by 2027, doubling the amount it currently spends. With more money, Japan will buy advanced weapons from the United States like Tomahawk missiles and work on building its top-level fighter jets, super-fast missiles, and armed drones. Initially, Japan sought to acquire the Lockheed Martin F-22 Raptor. However, the United States refused to sell the jet to any other country, thereby keeping its technology safe and leaving Japan at a disadvantage. So Japan made a bold choice to design and build its sixth-generation fighter jet. It's a challenging project, but if they succeed, Japan could end up producing one of the world's best warplanes and become a major player in the arms market. Between 2009 and 2010, Japan's Ministry of Defense took a deep look into fighter jet technology. From this work came the idea of the I-3 fighter, which stands for Informed, Intelligent, and Instantaneous. This jet was designed to be a stealth fighter capable of detecting and engaging other stealthy planes. It would come equipped with a powerful radar system, smart sensors, and the capability to communicate with external drones and sensor stations during battles. All these features were meant to give Japan a big advantage in controlling the skies around its region. The I-3 fighter could also carry new types of weapons, such as laser guns, known as light-speed weapons, that could instantly destroy incoming threats. As expected, China responded to Japan's plan with harsh words, accusing Japan of fabricating the China threat as a pretext for building more weapons. However, Japan is pushing forward, determined to rely more on itself and defend its territory. To turn their ideas into reality, Japan created a test plane called the Mitsubishi X-2 Shinshin. The X-2 was designed with a look similar to that of modern fifth-generation fighters, such as the Lockheed F-22 Raptor. Its size was comparable to that of the Swedish Saab JAS 39 Gripen. Measuring approximately 14 meters in length with a wingspan of 9 meters, it weighed almost 13 tons and was equipped with strong turbojet engines featuring 3D thrust control, which provided it with remarkable agility and the ability to fly at supersonic speeds. One of the most notable features of the X-2 was its fly-by-optics system. Instead of using traditional cables, it utilizes optical fibers, which enable faster data sharing and better noise handling. Its radar, called the multifunction RF sensor, was built with an active electronically scanned array, known as AESA technology, allowing it to switch across different signals for jamming, communication, and possibly even using microwave weapons. Another notable feature was its self-repairing flight control system. If the plane's flight surfaces got damaged, it could detect the problem and adjust by using the parts that still worked, keeping the jet flying safely. For its test flights, the X-2 used two XF-5 engines. The work was led by Japan's Acquisition Technology and Logistics Agency. They made a small demo plane called the Advanced Technology Demonstrator, or ATDX for short, which flew 34 missions in 2016 and 2017. ATLA also ran 14 other programs focused on building the key components needed for a real stealth fighter, such as improved sensors, faster data links, and concealed weapon bays. The prototype was a big success. Many of the new systems tested on it will likely be used in Japan's future sixth-generation fighter jet. The twin-engine plane had a sleek and smooth shape, standing about 4.51 meters tall. Its cropped delta wings and special extensions allowed it to keep flying safely even at high angles. Two vertical fins at the rear helped improve both its flight capabilities and stealth. It was piloted by a single pilot and featured a retractable tricycle landing gear setup, smooth control surfaces, and two rectangular air intakes positioned adjacent to the cockpit. The special S-duct design also made its airflow smoother and more conducive to speed. After the success of the X-2 project, Japan's Ministry of Defense started working on the Mitsubishi FX in 2020. This new twin-engine stealth fighter is designed for air battles and is planned to be even larger than the F-22, which has earned it the nickname Godzilla. Its large size would give it a longer flight range and the ability to carry a greater number of weapons. It is also designed to have a robust network system and carry more missiles than the F-35. Engineers experimented with various exterior designs using 3D models and specialized computer programs. The primary goals were to make it extremely fast, highly agile, and exceptionally stealthy. To make it lighter and more flexible, the FX would ditch hydraulic systems and utilize electronic components instead. It would also use strong glue molds instead of regular bolts and screws. 2 XF-9 engines would power the plane, providing it with more than 20 tons of thrust. These engines would have special 3D thrust nozzles to help them turn more quickly and remain hidden. For its weapons and defense, the FX would feature an advanced mix of sensors to track and engage stealthy enemy planes. It would carry an active electronically scanned radar, a passive radio wave sensor, and an infrared camera. All of these would utilize gallium nitride technology to better detect targets that are normally difficult to see. The new jet would also feature a sophisticated radio system that could jam enemy signals worldwide, enabling it to intercept and counter incoming missiles. Pilots would receive a high-tech helmet equipped with a wide field of view, dual-eye displays, colorful screens, voice control, and 3D sound. The FX's stealth features would include twisted air ducts, hidden weapon bays, materials that absorb radar waves, and new metamaterials to make it even harder to detect. A plasma stealth system would generate short plasma bursts to deflect radar waves, thereby further protecting the plane. Beyond conventional armaments, the FX will be armed with a microwave cannon to disrupt incoming missiles. It will also have the ability to deploy combat support unmanned aircraft drones, serving as loyal wingmen to the fighter. These drones will aid in target identification, munition deployment, and the deflection of incoming missiles. If the FX Godzilla lives up to even a fraction of its potential, it could provide the Japanese armed forces with a formidable warplane surpassing anything in today's skies. Furthermore, it has the potential to propel Japan into the global weapons development market, solidifying its position as a military manufacturing powerhouse. Another important job for the FX Godzilla is to replace Japan's current F-2 fighter jets during the 2030s. It's clear that Japan also draws some ideas from the US regarding the FX's design and functionality. Japan even bought some F-35s to use alongside the FX once it is ready. In 2022, rumors started flying that Japan and the UK might join forces by merging Japan's FX project with the UK's Tempest fighter program. By December 2022, the partnership was officially announced, and Italy joined the team as well. Initially, the UK sought to collaborate with France and Germany through a program called the Future Combat Air System. However, after numerous arguments and delays, the UK ultimately decided to collaborate with Japan and Italy instead. This new collaboration is a significant win for both parties. Japan secures strong partners who can help it sell military planes overseas, an area where it lacks substantial experience and expertise. The UK gets serious partners without the problems it faced before. Together, they aim to develop a powerful 6th-generation stealth fighter that could revolutionize the future of air combat. Big companies were given key tasks. Mitsubishi Heavy Industries from Japan and BAE Systems from the UK are leading the project. BAE is also working on the main body of the jet. Japan's IHI Corporation and Rolls-Royce are building the engines. Italy's Leonardo is responsible for the electronics, while MBDA UK handles the missile systems. After Japan and Britain teamed up, they also began working together on radar systems through a project called Jaguar, an acronym for Japan and Great Britain's Universal Advanced Radar Frequency System. The new fighter will be about 30% bigger than the Eurofighter Typhoon. Its weight without fuel will be close to that of the American F-15 Eagle. The plane will have a sharp delta wing with a 50-degree sweep. The wingspan will be around 54 feet, and the total wing area will be about 12,200 square feet, almost the same as the wing size of an Airbus A320. A model of the new fighter was first shown at the Farnborough Air Show in 2024. It features a trimmed delta wing, which enables it to fly faster, travel farther, and carry more weapons and fuel. However, it may not be as adept at quick turns and sharp maneuvers as Japan's original FX design. British aviation journalist Gareth Jennings pointed out that the G-SHAP's broad wings look a lot like those of the old American F-111 Aardvark bomber. The F-111 used to fly low to stay hidden from radar, but the G-SHAP will mainly depend on stealth and long-range missiles to remain safe. This plan is similar to the FB-22, a bomber version of the F-22 Raptor that never entered service. Unlike the FB-22, which was built solely for support, the GCAP is designed to engage other planes and strike ground targets. All three countries working on the G-SHAP already use F-35B stealth fighters, except the UK, which also flies the F-35A. However, they still sought a jet that could carry more weapons than the F-35 and could be sold to other countries without the stringent restrictions associated with the American F-22 Raptor. Japan also plans to fit the G-SHAP with its high-tech missile systems. These will include the MBD-A Meteor, the Spear-3, and the ASM-3, which is a Japanese anti-ship missile. Japan and Britain are also collaborating to develop a new medium-range air-to-air missile, known as the Joint New Air-to-Air Missile. Rumor has it that the JN-8M will feature a radar system manufactured by Japan at the front and a Meteor ramjet engine from Britain at the rear. Still, it may be slower than the Meteor, which can travel at over Mach 4. The JN-8M's top speed is expected to be around Mach 3.5. As for the schedule, the first flight of a Tempest concept demonstrator, a prototype built to test new technology, is planned for 2027. According to the UK Ministry of Defence's Director for Future Combat Air, this test plane will give a strong idea of what the final GEAP fighter will look like. Work on the joint engine demonstrator began in 2024, with the UK investing an initial £30 million in planning, digital design, and innovative construction methods. An additional £200 million from the UK will be allocated toward building a full-size engine for testing. This work will also create many skilled jobs, including at Rolls-Royce's Filton site in Bristol. The first flight of the Tempest is expected to happen in 2035. It will eventually replace the Eurofighter Typhoon in Italy and the UK, as well as the Saab Gripen in Sweden. During its production, they plan to use 3D printing to make parts. Leonardo is also building a new type of radar system for the Tempest. Instead of using a single large radar, this new system will utilize numerous small antennas and mini receivers to collect vast amounts of information from both the sky and the ground. Like other sixth-generation jets, the Tempest is likely to utilize artificial intelligence to control drones, building upon the concept of the loyal wingman. The cockpit will feature augmented reality, making the plane even more advanced. Fast progress and teamwork between countries will be crucial if the Tempest hopes to keep pace with China and Russia, who are also developing powerful new jets. Still, not everyone is pleased about Japan's more ambitious military plans. Kyoji Yanagasawa, a former defense leader, is one of the few who have spoken out. He says that having more potent weapons will not scare away enemies. Instead, he thinks Japan should focus more on talking and making peace to avoid wars. Yanagasawa worries that if Japan builds up its army too much, it could cause more trouble than it solves. He believes that growing the military might deter neighboring countries and make Japan a more attractive target. His view focuses on the difficult choice Japan faces: how to maintain safety without exacerbating tensions with its neighbors. Many experts believe Japan's push to enhance its military capabilities stems from a rapidly changing world. With China growing stronger and North Korea building up its nuclear weapons, Japan feels it might be left exposed. There are also concerns that the United States, Japan's largest ally, may not always be able to fully protect it, especially if problems erupt in different parts of the world simultaneously. The debate over Japan's new defense plans shows the complex situation the country faces as it seeks to strike a balance between peace and security. While many people agree that Japan should be able to defend itself more effectively, others are concerned about potential future developments. If Japan overextends its military, will it truly make the country safer, or will it merely add more tension to East Asia? Yasuo Hasebi, a constitutional law expert at Waseda University, mentioned how hard it is to know if a strike is truly preemptive until after it happens. He also argued that the government could claim that simply possessing these weapons for defense, even if they are never used, still aligns with Japan's peace-focused constitution. Although the law isn't clear on the matter, the government firmly insists that its plan is legal. Hyperspeed noted that because the government claims it is allowed, questioning it becomes very difficult. Surprisingly, there has been little resistance from Japan's public, media, courts, or opposition parties regarding whether this new military path aligns with the Constitution. The government has also not clearly explained how its actions comply with the law. From the U.S. perspective, Japan's growing military presence can be viewed in two ways. Zach Cooper, a senior fellow at the American Enterprise Institute, notes that Japan is bolstering its weapons and defenses, which the U.S. already supplies through its alliance with Japan. He believes part of the reason is Japan's fear that America might not always be a steady partner. That fear partly comes from the time when President Donald Trump questioned the value of old alliances. Japan's plan also shows that it learned from Ukraine's fight against Russia. Experts believe that when a country demonstrates its commitment to self-defense, its allies are more likely to step in and provide assistance. Japan hopes that by demonstrating its ability to stand up for itself, it will receive even more substantial support, especially from the United States. Forget everything you thought you knew about tanks. While the powerful M1A2 Abrams and the formidable KF-51 Panther grab the spotlight with their firepower, Japan's Type 10 is quietly changing the game. Sleek, fast, and adaptable, this tank is built for more than just combat. It's designed for precision and speed. Whether it's taking on enemy tanks, making quick strikes, or handling the most challenging battle scenarios, the Type 10 excels. But what makes this Japanese beast stand out from the rest? Could it be more formidable than the United States and Germany's battle tanks? Join us as we explore all of the intriguing reasons why this Japanese tank will change everything. 70 years ago, on July 5, 1943, the Battle of Kursk began, becoming one of the deadliest tank battles in history. The skies over the Russian city of Kursk exploded with firepower as German tanks, including the fearsome Tigers and massive Ferdinand tank destroyers, charged into battle. These German tanks were deadly machines, built to crush their enemies with overwhelming force. One German tank commander even managed to destroy 22 Soviet tanks in under an hour, demonstrating the power of these war machines. But the Soviets didn't back down. With over 6,000 heavy tanks of their own, the Russian forces fought with determination. They used close-quarters tactics, planting mines under the German tanks to disable them. Despite the Germans' powerful tanks, the Russians' fierce resistance and dangerous strategies turned the tide of the battle. After 8 intense days, the German tanks were worn down and unable to continue their attack. The Soviet counteroffensives then crushed the German forces, delivering a crushing blow to their ability to fight on the Eastern Front. The Battle of Kursk proved just how deadly tanks can be, changing the course of the war and altering who holds the upper hand. Tanks, with their armored shells and powerful guns, have long been feared on the battlefield. Whether it's the terrifying German Tigers or the Soviet T-34s, these machines have always been designed for sheer destruction. Their firepower and strength make them some of the most lethal weapons ever built for war. In modern times, tanks remain just as deadly. Though air power has dominated modern warfare, the presence of these massive machines continues to intimidate adversaries. The US and Germany have long led the way in tank development, but now Japan has joined this exclusive group. With the introduction of its own advanced Type 10 tank, Japan might just have secured its place among the nations that wield some of the world's most potent and formidable military machines. The development of the Type 10 main battle tank began in 2002 by Japan's Technical Research and Development Institute. By 2006, a prototype was ready, and testing took place in 2007 and 2008. After completing further trials on shooting and networking, TRDI finished the development in 2009 and started full production in 2010. The Type 10 MBT was designed to replace Japan's older Type 74 and Type 90 tanks. It features significant upgrades in areas like mobility, protection, firepower, and overall performance, making it one of the world's top 10 battle tanks. Japan's journey with modern tanks began in the 1960s when it became clear that the older Type 61 wouldn't be able to keep up with newer Soviet designs like the T-62. To address this, Mitsubishi Heavy Industries began developing a new tank, which became the Type 74. The first prototype was completed in 1969, and the tank entered full production by 1975. The Type 74 was designed using ideas from Western tanks, placing it in the same category as the M60 Patton and the Leopard 1. However, by the time the tank entered service in the 1980s, newer and more advanced Western designs were already available, leaving the Type 74 outdated even before it fully joined the Army. Production ended in 1989, and only about 890 units were built. The Japanese Ground Self-Defense Force was the only operator of this tank, as Japanese laws prohibited military exports. The Type 74 design included a cast turret similar to that of the French AMX-30. It was armed with a 105mm rifled gun, which was the British L7 gun made under license in Japan. Early prototypes of the Type 74 had an autoloader, but it was removed due to complexity and cost. The tank was initially equipped with high explosive rounds, but later upgraded to more advanced armor-piercing rounds. It carried 55 rounds for the main gun, with 14 rounds stored in the turret and the rest in the hull. One of the exceptional features of the Type 74 was its fire control system, which was revolutionary at the time. It was the first tank in the world to include a computer for ballistic calculations and a laser rangefinder. Later versions of the tank were upgraded with infrared imagers, which made the tank even more effective in combat. The secondary weapons included a 7.62 coaxial machine gun and a 12.7mm machine gun mounted on the roof. The Type 74 also featured an all-welded hull, NBC protection, also known as nuclear, biological, and chemical protection, and an automatic fire suppression system. It had a crew of 4, a commander, gunner, loader, and driver. Over the years, the Type 74 became outdated, and Japan moved forward with the development of the Type 10, which is now one of the most advanced tanks on the global stage. The Type 10 is an embodiment of Japan's military innovation and a formidable force in modern armored warfare, joining a select group of nations, including the US and Germany, with access to such powerful battle tanks. With its cutting-edge technology, high maneuverability, and superior performance, the Type 10 is now a key player in Japan's defense strategy, marking a new chapter in the evolution of military tanks. The Type 10 MBT is equipped with a sophisticated turret featuring an automatic loading system. This advanced system allows the turret to rotate 360 degrees, ensuring it can track and target enemy forces from any direction. The tank is armed with a powerful 120mm L44 smoothbore gun, which is manufactured by Japan's Steelworks under license. This gun offers immense firepower and precision, making it a formidable weapon on the battlefield. The 120mm L44 smoothbore gun is capable of using all standard NATO 120mm rounds, as well as those specifically designed for the Japanese Ground Self-Defense Force. However, the most intriguing feature is the Type 10's ability to fire the Type 10 APFSDS, or armor-piercing fin-stabilized discarding sabot round. This unique round is specially designed for the Type 10 and can only be fired by this tank's gun, giving it a significant edge in terms of firepower over its competitors. One of the key innovations in the Type 10 is the auto-loading mechanism, which eliminates the need for a dedicated crew member to load the gun. As a result, the Type 10 operates with a smaller crew of just 3, the commander and gunner in the turret, and the driver in the hull. This reduction in crew size contributes to the tank's efficiency and overall performance, while also minimizing the risk to personnel. The auto-loading mechanism is housed in the rear section of the turret, giving the tank its distinctive appearance. The gun is aimed with the help of a set of advanced sighting arrays that provide 360-degree visibility, both day and night. These sighting systems offer exceptional target identification and tracking capabilities, even in low visibility conditions. Additionally, the barrel of the gun is fitted with a muzzle reference sensor located to the right of the muzzle. This sensor plays a crucial role by detecting any slight deformation or warp in the barrel, ensuring the gun maintains optimal accuracy at all times. However, the most important question is how effective and formidable it really is when compared to battle tanks from other developed nations. So how does the Type 10 compare to the United States M1A2 Abrams and the German Kf-51? The M1A2 Abrams is one of the strongest and most respected tanks in the world, used by the U.S. Army. Weighing about 68 tons, it combines powerful armor, heavy firepower, and impressive speed for its size. Its main weapon is a 120mm smoothbore gun, capable of firing various types of ammunition. This allows it to destroy heavily armored targets with ease and gives it a big advantage in battle. The tank is operated by a crew of 4 people, a commander, gunner, loader, and driver. Inside, it is packed with advanced technology like thermal imaging, computerized fire control, and reactive armor, which helps it survive enemy attacks. With these features, the M1A2 is not just tough, it's smart too, making it a fearsome opponent on any battlefield. The M1A2 was officially approved for production in 1990 as an upgraded version of the M1A1 Abrams. At first glance, the two tanks look pretty similar, but the M1A2 introduced major improvements on the inside. On the outside, the most significant changes include a redesigned commander's weapon station and a new commander's independent thermal viewer, located near the loader's hatch. These upgrades help the tank become even more powerful and effective. One of the most impressive innovations inside the M1A2 is the Inter-Vehicle Information System, also known as IVIS. This smart system lets different vehicles share information with each other instantly and automatically. Thanks to an onboard navigation system, commanders can track their units' locations in real time without distracting the crews. IVIS also lets soldiers quickly mark enemy positions, send artillery requests, and share mission orders. Everything is fast, automatic, and smooth, helping the whole team stay connected in the heat of battle. To keep this valuable information secure, all IVIS data is transmitted through a secure SINC-GARS radio system, making it difficult for enemies to intercept. The M1A2 also improves on the hunter-killer method first used by Germany's Leopard 2 tank. With the new commander's independent thermal viewer, the tank commander can now search for targets at any time, day or night, and even through smoke or bad weather, while the gunner focuses on firing. This speeds up the tank's ability to find and destroy enemies before they even know what's happening. Besides IVIS and CITV, the M1A2 also receives several electrical upgrades. Power is now distributed through multiple paths within the tank, so if one part is damaged, electricity can still reach critical systems via backup routes. The driver's controls were updated with a new digital display, and the gunner's primary sight was stabilized better, meaning more accurate shots even when the tank is moving. In 1995, the U.S. Army introduced another improvement, known as the M1A2 SCPOR System Enhancement Package. This upgrade aimed to bring all M1 and M1A2 tanks up to the same modern standard. Major changes included a new auxiliary power unit placed under the armor and an air conditioning system to keep the crew cool during long missions. Inside the tank, upgrades included a color display for the IVIS system, a full-size keyboard, digital maps, graphic generation tools, and even voice recognition. The gunner's sight, the intercom, and radio systems were also improved to make communication faster and clearer during fights. Production of brand new M1A2s stopped after 627 tanks were built. However, the Army began upgrading 547 older M1s to the new M1A2 SCP standard, which involved rebuilding the turret almost completely. Existing M1A2 tanks were also retrofitted to match the SCP upgrades, ensuring all U.S. Army tanks stayed deadly, smart, and ready for modern combat. Comparing the capabilities of the American M1A2 Abrams and Japan's Type 10 is quite interesting. Both are fierce in their own ways, but they were built with very different ideas in mind. One is a massive heavyweight made to crush anything in its path. The other is a fast and smart fighter, made to dance around enemies with speed and technology. Let's dive into what makes these two tanks so unique. First, let's talk about size and weight. The M1A2 Abrams is a giant, tipping the scales at about 68 tons. It's built like a fortress on tracks, able to take a beating and keep moving. On the other hand, the Type 10 is much lighter, weighing around 44 tons. Japan designed it to be fast and agile, perfect for the country's many mountains and tight spaces. While the Abrams is like a heavyweight boxer, the Type 10 is more like a quick and clever martial artist. Both tanks pack serious firepower. The Abrams is armed with a 120mm smoothbore gun that can fire a variety of NATO rounds. This gives it great flexibility against different types of targets, from enemy tanks to bunkers. The Type 10 also uses a 120mm smoothbore gun, built specially by Japan Steelworks. It can fire regular NATO rounds too, but it also has a special trick up its sleeve: the Type 10A PFS-DS round, a unique armor-piercing shell designed for maximum punch against modern armor. The crews inside these tanks are a little different too. The M102 Abrams needs 4 soldiers to operate: a commander, a gunner, a loader, and a driver. In contrast, the Type 10 only needs 3 because it has an automatic loading system that handles the job of loading shells into the gun. This not only saves space inside the tank, but also makes it a little lighter and faster. Technology is where both tanks really shine. The M1A2 Abrams is loaded with high-end tech, including thermal imaging to spot enemies day or night, a commander's independent thermal viewer that lets the commander find and mark targets even while the gunner is firing, and the smart inter-vehicle information system, which allows tanks to talk to each other and share battlefield information instantly. The Type 10, while smaller, is no slouch in the technology department either. It has full day and night sights, a muzzle reference sensor that checks if the barrel has warp during battle, and a smart communication system that lets it share data with other units in real time. Plus, the Type 10 can actually adjust its suspension to lower or raise itself, giving it better firing angles or making it harder to hit. Armor is another big difference. The M102 Abrams is like a tank in the truest sense. It uses thick composite and reactive armor to survive direct hits. Meanwhile, the Type 10 uses modular armor, which means armor plates can be swapped out depending on the mission. If speed is needed, it can go lighter. If protection is needed, it can bulk up. Eventually, the choice between these two tanks comes down to what one needs on the battlefield. The M1A2 Abrams is a fearsome force, made to dominate in heavy, head-on battles where firepower and protection matter most. The Type 10 is made for fast, smart warfare, where quick moves, good communication, and flexibility win the day. But how do both of them compare to the renowned and formidable KF-51? The defense world has been buzzing about the KF-51 Panther tank, and it's easy to see why. At the heart of its power is a brand new gun called the Future Gun System. It's not just a new paint job. This 130mm gun is a game changer. It's bigger than the usual 120mm guns and fires faster, reaching targets up to 3,500 meters away, about 1,000 meters farther than most tanks. This gives the Panther a considerable advantage. It can hit enemies before they can even fire back. The Future Gun System isn't just strong, it's smart. It can fire regular armor-piercing and explosive rounds, but it also has special programmable ammo that can explode in the air, hitting drones and hidden soldiers. However, it does carry fewer rounds than other tanks. Luckily, the Panther's autoloader system makes up for this. While many Russian tanks have utilized autoloaders for years, this is a new development for German tanks. It allows faster shooting, 2 rounds every 3 seconds, and gives the tank a lower, harder-to-spot profile. Inside, the Panther has 4 seats instead of the usual 3. The extra seat can be used by a drone operator or a company commander. And the Panther isn't just about heavy guns, it's loaded with extra gadgets too. It has a 7.62mm machine gun mounted on top, called the N, that can shoot almost straight up, mainly to defend against enemy drones. It also carries 4 Israeli Hero 120 loitering munitions, which are flying bombs that can circle the sky for an hour before striking. Defense doesn't stop there. The Panther has a top attack protection system to guard against missiles attacking from above. If that fails, there's the rapid obscuring system, which blasts special smoke to block enemy sensors. And if all else fails, the Panther is wrapped in explosive reactive armor that punches back at incoming weapons. But the Panther is not just muscle, it's brains too. Thanks to NATO's new tech rules, it's designed to easily accept new upgrades. It can send live info across the battlefield, acting like a scout and a fighter all at once. Using small drones, the Panther can spy far ahead without putting itself in danger. For all this gear, one might think the Panther would be slow. Not at all. It weighs just 59 tons, lighter than the 70-ton M1 Abrams, and its 1,500 horsepower engine gives it a power-to-weight ratio of 25. This means it can climb steep hills, cross trenches, ford deep water, and still hit speeds of 70 kilometers per hour. It can also travel over 500 kilometers on a single tank of gas. When compared to tanks like America's M1 Abrams and Russia's T-14 Armata, the Panther stands out. The M1 Abrams is powerful but heavier and less nimble. The T-14 has advanced ideas but has struggled with real-world use. The Panther, combining firepower, protection, speed, and smart tech, looks to be the best of the three. Japan's military history dramatically turned in the early 1900s when they revolutionized naval warfare by creating the first aircraft carrier. But everything changed when they stepped back from military power and chose peace instead. That peace lasted for many years. But now things are different. With China becoming more aggressive, Japan has strengthened its navy again. Thanks to its strong $4.9 trillion economy, they have built new high-tech aircraft carriers equipped with cutting-edge fighter jets. The message to China is clear: Japan will stand up for itself. But how do they match up against China's expanding navy? And what does this mean for the future of the Pacific? Join us as we examine Japan's new aircraft carriers and their hidden message to rival countries. Back in 1922, Japan changed how naval battles would be fought forever. They built the Hosho, the world's first real aircraft carrier. But it was not just for show, it was their testing ground. Japanese engineers used it to figure out everything about carrier operations: how planes should take off, how they should land, and how the whole ship and aircraft system could work together smoothly. The Hosho proved that aircraft carriers were the key to controlling the seas. Japan went all in, building carrier after carrier: the Akagi, Kaga, Soryu, Hiryu, Shokaku, Sukaku, Taiho, and Unryu. Each new ship was bigger and better than the last, showing just how powerful Japan's navy had become. But it wouldn't last. The Unryu, their final carrier, sank in 1944 during World War II, and just a year later, atomic bombs hit Japan, changing everything. After the atomic bombs hit Hiroshima and Nagasaki, World War II, history's deadliest conflict, came to an end. Japan made a huge change. It would be a peaceful nation. No offensive weapons were allowed. That meant no long-range missiles, no nukes, and no aircraft carriers. They could only have weapons to defend themselves. Despite this, Japan found a clever workaround. They built two helicopter carriers that were as big as regular aircraft carriers, bigger than Italy's. For years, people wondered if these were just aircraft carriers in disguise. Now there is no more guessing. With China becoming more aggressive, Japan has officially turned these ships into proper aircraft carriers. They are called the Izumo class and are Japan's first aircraft carriers in over 70 years. The ships Izumo and Kaga joined Japan's navy in 2015 and 2017. Each weighs 27,000 tons and can carry 28 helicopters. But what makes them special is their design. These ships were built to be easily converted into full aircraft carriers. They already have most of what they need. The rest can be added quickly when required. So while Japan calls them helicopter carriers, they are aircraft carriers in waiting. Let's explain what the debate is all about. To get the full picture, we need a clear picture of what a helicopter carrier is and why it matters so much to any country with one. A helicopter carrier is a special type of aircraft carrier that is built mainly for helicopters. It has a big flat deck for aircraft to land and take off. This deck can run the whole length of the ship, like on the Royal Navy's Ocean, or it might only cover part of the ship, usually the back end, like on the Soviet Navy's Moskva class or the Chinese Navy's Type 0811A. Most helicopter carriers also have an indoor hangar deck below, where they can store and fix their helicopters. These days, it is tricky to say what counts as a pure helicopter carrier. Things got more complicated when planes like the Harrier and F-35 came along. These can take off and land vertically. Take the United States Navy's Wasp-class ships. They carry 6 to 8 Harriers plus more than 20 helicopters. So really, only the smaller ships that can't handle these special planes, or older ships from before the Harrier existed, are truly helicopter carriers. Many modern ships that can work with these vertical takeoff planes are called light aircraft carriers instead. Some ships, like the Wasp class, can also move troops like Marines and get them to shore, which is why they're called landing helicopter docks. On the other hand, a full-blown aircraft carrier is a warship that acts as a floating airport, with a long flat deck and storage areas below for aircraft. It lets naval forces use aircraft thousands of miles from home without needing land-based airports. Aircraft carriers have come a long way since they first appeared as wooden ships carrying single observation balloons in the 1900s. They are massive nuclear-powered vessels that can carry anywhere from 40 to 60 different aircraft, from fighter jets and attack planes to helicopters and early warning aircraft. Now back to Japan. The Kaga is a powerful ship in Japan's Navy. Japan officially calls it a multi-purpose operation destroyer. It is the second ship of its kind, following its sister ship, the Izumo. The Kaga is from an old Japanese province, now part of Ishikawa Prefecture. Construction began in October 2013 at Japan Marine United's Yokohama shipyard. The ship was launched in August 2015 and entered service in March 2017. The Kaga's flight deck is built for action, with 5 spots where helicopters can land or take off at the same time. This makes it similar to American ships, such as the Wasp and America class. Experts noticed something interesting about Japan's new helicopter destroyers in 2010. It looked like they were designed to handle more than just helicopters. People started speculating that the ships could launch fighter jets like the V-22 Osprey and the F-35 Lightning II. And guess what? They were right. Japan announced plans to upgrade the Kaga and Izumo to carry the F-35B, a special version that can take off and land vertically. They started fixing them up in 2022, and it would take about 5 years to get each one ready. The planned changes to Kaga will be more expensive and extensive than the work done on its sister ship. The modifications include reshaping the front of the vessel. The initial phase of construction finished in the early 2024. In 2019, Prime Minister Shinzo Abe approved a defense budget of 26.2 trillion yen, or $238.72 billion to be distributed over 5 years. This money would cover upgrading Izumo and Kaga and buying 147 F-35A and F-35B stealth fighters. The Mainichi Shimbun newspaper reported that Japan's Air Self-Defense Force plans to get 42 F-35B aircraft. They will bring in 18 by 2023, 6 in 2024, and 2 in 2025, and the first group will form one squadron of about 20 planes. Defense Minister Nobuo Kishi picked Nutabaru Air Base in Miyazaki Prefecture, Kyushu, to host these F-35Bs. The base sits close to the Southwest Islands, including Okinawa, and near the Kure Base in Hiroshima Prefecture, where Kaga is stationed. The Kaga stretches 814 feet, or 248 meters, and weighs 27,000 tons. That makes her the biggest ship in Japan's maritime self-defense force. She is a light carrier similar to Italy's Cavour and about the same size as many countries' amphibious ships, but she is much smaller than supercarriers. Take the USS George H.W. Bush, which is 1,092 feet, or 333 meters, long and weighs over 100,000 tons and protects itself with 2 phalanx and 2 CRAM close-in weapon systems. In 2018, Kaga sailed through the South China Sea and Indian Ocean as part of the Indo-Southeast Asia deployment exercise. The trip showed Japan's presence in these key waters, with stops in the Philippines, Singapore, Indonesia, India, and Sri Lanka. Donald Trump visited Japan, and during his visit, he visited Kaga in Yokosuka. While there, he gave a speech saying that many United States allies were not spending enough on their militaries while taking advantage of America's big defense budget. He praised Japan for buying American equipment and wished them well as they entered the Reiwa era. Let us look at Kaga's sister ship, Izumo. Work started on the first Izumo-class ship in 2011 at IHI Marine United's Yokohama yard. The fiscal 2010 budget set aside 113.9 billion yen, about 1.5 billion United States dollars, for this project. These ships were meant to take over from the Shirane-class destroyers, which were set to retire in 2014. The ship can accommodate up to 28 aircraft, though this drops to 14 when carrying larger aircraft. For now, they plan to equip it with 7 anti-submarine warfare helicopters and 2 search and rescue helicopters. The ship can also transport 400 troops and 53.5-ton trucks or similar equipment. The flight deck features 5 spots where helicopters can land and take off simultaneously. In 2010, defense analysts at Forecast International noticed something peculiar about the Izumo-class helicopter destroyers. Certain design features hinted that these ships might be capable of handling more than just helicopters. Despite this speculation, the Ministry of Defense and the Japanese Maritime Self-Defense Force remained tight-lipped, never acknowledging the possibility of deploying fixed-wing aircraft on these vessels. Adding to the mystery, the Izumo class lacks the typical features of launching conventional fighter jets, such as a ski jump ramp or a catapult system. This suggests that if these ships were indeed to operate fixed-wing aircraft, they would be limited to short takeoff, vertical landing aircraft. Japan bought the Lightning II fighter jet's regular takeoff and landing version, and they have also considered getting the F-35B model, which can take off in short distances and land vertically. This version could work on a modified Izumo-class ship. In December 2018, Japan announced plans to update their defense rules and buy 42 F-35B fighters to use on Izumo. The Izumo-class ship serves as a multi-purpose operation destroyer. When empty, it weighs 19,950 metric tons, or 19,630 long tons. When carrying a full load, the ship's weight increases to 26,000 metric tons, which equals 26,000 long tons. The Izumo measures 248 meters long, or 813 feet and 8 inches. Its beam spans 38 meters, which is 124 feet and 8 inches across. The ship stands 23.5 meters tall, equal to 77 feet and 1 inch. It has a draft of 7.5 meters, or 24 feet and 7 inches. It uses a COGAG system with 2 shafts and 4 GE/IHILM 2500 IEC gas turbines for power. The ship can move faster than 30 knots, about 35 miles or 56 kilometers per hour. The ship can hold 970 people, including crew and troops. It uses the OYQ-12 combat direction system and the FCS-3 fire control system for tracking and combat. It's equipped with an OPS-50 ASA radar, OPS-28 surface search radar, and an OQQ-23 boost sonar for underwater detection. The ship has several electronic warfare systems to defend against threats. These include the NOLQ-3D1 electronic warfare suite, Mark 36 SRBOC countermeasures, anti-torpedo mobile decoys, and floating acoustic jammers that can confuse enemy sensors. For weapons, the ship carries 2 Phalanx close-in weapon systems and 2 CRAM close-in weapon systems. In terms of aircraft, it typically operates with 7 anti-submarine warfare helicopters and 2 search and rescue helicopters. At most, the ship can handle 28 jets in total. After joining the fleet at Yokosuka Port in Japan in March 2015, Izumo quickly got to work. By August of that same year, it teamed up with the Coast Guard ship Izu for a major emergency drill in Tokyo. During this practice run, both ships served as medical centers where they could receive and sort injured people. A big moment for Japan's military was in May 2017, when the massive Izumo headed out on a mission that would make headlines, protecting an American supply ship near Japanese waters. This was not just any routine patrol. The United States vessel, Richard E. Byrd, was part of a bigger operation keeping tabs on North Korean missiles. What made this so special? It was the first time Japan had ever guarded a United States ship since they changed their military laws in 2016. However, this did not sit well with everyone back home. When the Izumo left port in Yokosuka, protesters showed up. They were worried that this kind of mission, especially using such a big warship, went against Japan's long-standing policy of having a military only for defense. This was more than just ships moving around in the ocean. Japan took a bigger step onto the world stage, showing they were ready to work more closely with their American allies. This was significant for a country that had stayed away from this kind of military teamwork for so long. In September 2021, Izumo trained with the British aircraft carrier Queen Elizabeth and other ships in the Pacific. By early October that year, Izumo hit another milestone when the United States Marine Corps F-35B fighters landed on its deck for the first time. Later, on May 31, 2022, Japan's Navy announced that Izumo would join RIMPAC 2022 along with two other Japanese ships, the destroyer Takanami and destroyer Kirasami. As of January 2025, about 50 aircraft carriers actively serve in 15 different navies worldwide. The United States operates 11 large nuclear-powered fleet carriers that use catapults to launch their planes. Each carries about 80 fighter jets, and their combined deck space is more than double that of all other nations. China, Britain, and India each run 2 aircraft carriers with sloped decks for takeoff. China is also building a third carrier that will use catapults like the American ones. France and Russia have one carrier that can handle between 30 and 60 fighter jets. Italy has 2 smaller carriers that work with vertical takeoff planes, while Spain and Turkey each have one ship that can carry both aircraft and troops. What makes aircraft carriers so special? Speed and size are the 2 big things that matter most for these massive warships. Think about it like this. An aircraft carrier needs to move fast. We are talking about speeds over 35 miles per hour. That is pretty impressive for something as big as a floating city. This speed does 2 important things. It lets the ship get where it needs to go quickly and helps planes take off better. See, when the vessel moves fast, it creates more wind over the deck, which gives planes an extra boost when taking off. This is a big deal for ships like Japan's Kaga and Izumo. The faster they can go, the easier for those jets to take off from their decks. Speaking of decks, that brings us to size. Aircraft carriers are huge, and they need to be. Look at ships like the American Ronald Reagan or France's Charles de Gaulle. All that space is needed for planes to take off, land, and park. The Japanese ships Kaga and Izumo are particularly interesting because they show how carriers can change over time. They started out carrying just helicopters, but now they are being upgraded to handle fighter jets, which sends a clear message to China and the rest of the world. Why is this such a huge deal for China? First and foremost, Japan protecting United States ships in China's backyard sent a crystal clear signal. China sees itself as the major power in Asia, and they are particularly sensitive about aircraft carriers. So naturally, when Japan started using the Izumo this way, it was like waving a red flag in front of them. Moreover, China had always used Japan's wartime past to criticize any military moves Japan made. As a result, they were especially unhappy seeing Japan's biggest warship working alongside American forces. From China's perspective, Japan was steadily breaking away from its peaceful, defense-only policy. Perhaps even more concerning for China was what this newfound teamwork represented. After all, Japan and America working together this closely made China increasingly nervous. Additionally, it demonstrated that Japan was prepared to take on a stronger military role in the region, which could directly challenge China's growing influence. Simply put, China was already dealing with American ships in the region. On top of that, they had to worry about Japanese ships protecting American ships too. Understandably, this created twice the concern for their military planners. In the end, this situation pushed China to dramatically speed up its naval buildup, especially its aircraft carrier program. They looked at what was happening and concluded they needed to match this show of force. That's precisely why China has 3 carriers, even more currently in the planning stages. Here is where things stand now. The Pacific has become a high-stakes chess game. But this is not just about warships. It is about a changing Asia, where old rivals are picking sides and building alliances. Japan, once committed to staying out of military matters, now stands shoulder to shoulder with America. And China, watching all of this unfold, pushes harder to become the region's top power. What started with Japan's clever workaround of calling aircraft carriers helicopter carriers has turned into something much bigger. It has shaped how countries built their navies, chose their allies, and showed their strength in the Pacific. As these nations eye each other across the waves, one thing's clear. The balance of power in Asia is not just shifting, it has already changed. For a long time, Japan has maintained a strictly defensive position in its military owing to its demilitarization by the United States after the Second World War. However, watching the Kremlin and China forcing conquests of militarily vulnerable nations, Tokyo joined forces with the United Kingdom and Italy in founding the Global Combat Air Program toward the creation of next-generation fighter jets. Could Japan be leaning towards a more proactive military approach? How has Russia taken this news? Join us as we discuss how Japan's new fighter jet rattles Russia. Over the years, Japan has maintained peace in its military structures, but it wasn't always so. Before the mid-1940s, they were a part of the massive military force under Emperor Hirohito that worked in tandem with Hitler's Nazi Germany forces and the Italian forces during the Second World War. Their improved technology and daring spirit to go after the United States on their own turf in Pearl Harbor on December 7, 1941, became a calling card for their military strength. However, following the United States' decision to join the war and the atomic bombs released in parts of Japan, especially Hiroshima and Nagasaki, on August 6 and 9, 1945, the Japanese Empire surrendered their arms. They did not, at the time, have an answer for an atomic bomb. But not only did Japan have to surrender their arms, it also had to surrender some part of their rights as a sovereign state to the United States. Following their tragic loss to the United States during the war in 1945, America occupied Japan for 7 years, enforcing a new constitution, where Article 9 conveniently stops them from owning a military force. While some of the top Japanese lobbyists tried to fight against it, they failed, as the country had already set a precedent of war when they hit Pearl Harbor, and now the United States, which drafted the post-war constitution, was strong-arming them into total submission and dominance. Having no choice but to sign, Tokyo has always kept its nose clean, avoiding war, and quite reluctantly becoming a home to 14 of the biggest military bases that belong to the United States, including the Yokota Air Base in Tokyo, the headquarters of U.S. Forces Japan, the Kadena Air Base, the Yokosuka Naval Base, the Misawa Air Base, and other strategically located military bases for the sake of protecting Japan should a war ever be on the horizon. Although Tokyo is unable to create its own military, it has been afforded the luxury of having a self-defense corps called the Japanese Self-Defense Forces, or JFDF. While Japan has politically shied away from referring to these self-defense forces as military, they are trained in the same way that a military is trained. Although they are not allowed to wage war on another country, as the United States forces control that part, the JFDF is a highly trained elite force, which is very capable of defending their homeland on their own turf if push ever came to shove. Owing to their demilitarization, Tokyo had refrained from manufacturing offensive weapons or military technologies in order to keep honoring their agreement with the United States. While they continued to uphold that posture, the Indo-Pacific region suddenly developed a reputation for China, which has a plan to dominate Southeast Asia through conquest, taking their lands and occupying the targeted sovereign states with a principal government to whom they report back. A perfect example is China's decision to coerce Taiwan into submission. Beijing has completely ramped up its intensity to take over the South China Sea via maritime dominance. The Taiwanese president, Lai Ching-te, who has leaned more towards the West for assistance, including the United States, angers China with their decision to keep bridging the all-powerful West into Indo-Pacific regions, making conquest harder than it used to be in the past. In a recent speech at the 2025 Shangri-La Dialogue, the United States Secretary of Defense Pete Hegseth told the audience that China's attempt to conquer Taiwan by force could be imminent. Although China has made no comment about the situation escalating towards an all-out war, its consistent aggressive movement towards the South China Sea along the Taiwan Strait all points to war. Although Taiwan is not demilitarized like Japan, its army and military might not compare to the huge Chinese military force and their war technology, making any type of war between both countries asymmetrical. Tokyo, which has been watching from the sidelines as militarily vulnerable countries are up for grabs by bigger sovereign states, has kept its cool and continued to honor its agreement with the United States without a fuss. However, their concerns continued to grow in 2014 when the Kremlin annexed Crimea and Ukraine with the aim of taking over the territory and, by extension, all of Ukraine. Little by little, the Japanese government turned up its defense technology, upgrading it to offense. Although there has been no confirmation as to why Tokyo suddenly encouraged a spike in the creation of offensive military weapons, including fighter jets, the consistent threats of being gobbled up by a nation with a stronger military were not an uncommon theme, and they saw it too. Although they had the protection of the United States, other countries under the same type of pressure, particularly Taiwan, also have the protection of the United States, meaning that their military has a divided focus, a gamble that Japan was unwilling to take and would rather find a way to prepare for potential all-out war. By February 24, 2022, Japan's fears were officially confirmed as the world watched Russia take over Ukraine, moving in with military might and watching their fighter jets blow up Ukrainian infrastructure, their economy, and their people, with their biggest blowback being heavy economic sanctions from the United States, who are also trying to negotiate peace with the Kremlin rather than join forces with Ukraine to fight the oppressor. Although it is well documented that the United States has been sending reinforcements to Ukraine, including war funds and military support like the F-16 fighters, the war remains ongoing, and Ukraine seems to be on the losing side despite fighting the war on their own turf. These circumstances were enough to change the posture of the Japanese government towards military improvement. Ergo, in 2023, the Japanese government, supported by the United Kingdom and Italy, came up with the idea of a jointly run operation where they could safely develop a sixth-generation fighter jet that could send a message to other top military nations, including China, the United States, and, more importantly, the Kremlin. The initiative was announced on December 9, 2022, the same year that the Russo-Ukrainian threats of war since 2014 became an all-out war. The initiative creates an avenue for the three countries that are involved to merge their separate sixth-generation projects, which would include the United Kingdom-led BAE Systems Tempest developed with Italy and the Japanese Mitsubishi FX. Although Japan had been technically demilitarized, it kept its defense in check aerially, on the ground, and maritime. Aerially, they created an Air Defense Identification Zone, or ADIZ, a region of airspace in which a country tries to identify, locate, and control aircraft in the interest of national security. It is declared unilaterally and may extend beyond a country's territory to give the country more time to respond to possible hostile forces aggressively without sanctions from any organization. But what makes the Mitsubishi FX, or F3 as it is called unofficially, so special that it is added as a potential study guide for a new next-generation jet? The Mitsubishi FX is a technology developed out of necessity by local Japanese companies, especially since the United States stopped the export of the Lockheed Martin F-22 Raptor to foreign nations, which included Japan, which did not have the military to defend itself in the first place because it had been demilitarized by the United States. Caught in this dilemma, Tokyo responded by building a domestically developed fighter jet to replace the F-22, which was no longer an option for them. Between 2009 and 2010, Tokyo delved deep into research on the latest fighter jets at the time, but decided against building the exact same things and instead looked to create something about a generation higher. It was no longer just about defense. It was about proving a point to the United States, which had faltered in its promises to help rebuild an aging air fleet that needed to be changed as quickly as possible. Following their research, they came up with the I-3, which translates to Informed, Intelligent, and Instantaneous Fighter Jet. Being Japan's first conceptualized fighter jet of the sixth-generation ilk, it was retrofitted with different functionalities, including advanced radar systems to counter stealth technology of other fighters, receiving targeting information from other platforms like drones, fighters, and airborne early warning and control aircraft. Use of flyby optics reminiscent of the Kawasaki P1 to process information faster, stealth technology, gallium nitride semiconductors to improve radar performance, and a new, more powerful engine that could give it a burst of hypersonic speed, Mach 6 and beyond. While the I-3 could be deemed a successful project, it was not going to be the end-all be-all for Japan. They needed something different, something designed for real air superiority. Enter the FX twin-engine stealth fighter jet, The Japanese Ministry of Defense described it as a technology with sixth-generation abilities. The Japanese Ministry of Defense was very much in a competition with the rest of the world, but mainly the United States, which at the time could boast of one of the biggest fighters in the world, the F-22 Raptor, but it traveled at Mach 2, which is twice the speed of sound. While it could be very much within the scale of the fastest fighters in the world, it was nowhere near the potential of the FX, which was proposed to be 6 times faster than the speed of sound. The FX is said to be bigger than the F-22, which has earned it the nickname Godzilla from Bradley Perrett at Aviation Week. The large size indicates the Japanese Ministry of Defense desires the aircraft to possess a very long range and a large payload capacity, meaning that it can carry much bigger ordnance than the F-22 while traveling at Mach 6 speed, and also be able to hit its target without faltering. It was the game changer. Technologies tested in the X-2 technology demonstrator will likely be incorporated into the FX fighter. Defense Minister Taro Kono has stated that the FX will possess strong network capabilities and will carry more missiles than even the crown jewel of the United States' aviation fleet, the F-35 Lightning II. The FX was a statement design that repelled almost everything the Raptor had, ranging from replacing the usage of conventional hydraulic systems with electric actuators. According to Japan's Ministry of Defense's evaluation, the reason for selecting electric actuators over hydraulic systems is because of the complexity of designing the interior of the stealth fighter. However, other than speed, the FX was designed for more. The Japanese Ministry of Defense wanted a jet capable of multiple functions. For some context, there are aircraft that are only capable of hunter missions, meaning that they can only be useful to gather information on the enemy and for surveillance and reconnaissance missions. However, they are also accompanied by a specific aircraft that does the job of aiming and firing at targets, called a killer. Hence, should there ever be a need to scout for problems and take them out immediately when the opportunity arises, the military sends the hunter and killer aircraft, with one primed to take out the target and the other tasked with identifying the target. However, when designing the stealth shape of the FX, the internal weapon bay and intake air ducts must be accounted for. Consequently, problems arise with installing hydraulic system piping due to design considerations such as rigidity and length. Hence, the reason that they adopted electric actuators, as they work with wires instead of pipes, eliminating the constraints once and for all. This results in simplified installation and reduced restrictions, allowing more flexibility in designing the body of the aircraft. But what really makes the FX special is its lightweight. Imagine an aircraft so big it is called Godzilla, weighing just a little more than a Raptor, even though it is considerably bigger. This was exactly what the Japanese aircraft developers were willing to achieve. Ergo, they tweaked the manufacturing design so far from the conventional designs. For some context, regular aircraft are mostly built using fasteners like bolts, screws, and nuts together to put up composite materials during construction. However, the FX designers took care of the extra weight from the fasteners by using adhesive glue to join composite materials together. This method is dubbed the integrated fastenerless structure technology. Although the fastenerless technology took a bit of weight away, the real chunk of weight is taken away by the use of lighter building materials like aluminum alloys and carbon fiber reinforced polymer. But the question is, if an aircraft is going to be flying at an unconventional speed of Mach 6 and above and in full flight, how do the softer materials like the carbon fiber reinforced polymer and aluminum alloys handle the heat that comes from the friction when the aircraft flies at that speed without getting burnt? Owing to the use of materials like carbon fiber reinforced polymer and alloys, the Japanese designers employ a heat shield technology, meaning that they add a component designed to protect an object or a human operator from being burnt or overheated by dissipating, reflecting, or absorbing heat. The Japanese Ministry of Defense's research team believes that the new design methods that help reduce the weight of the aircraft not only shorten the required working man-hours by 66%, but also propose a bit of a solution for the avionics system. The avionics of this aircraft centers around its hunter-killer enablers, ranging from its navigation system to radar systems and sensors. To help the aircraft avoid detection, enabling its hunter version, the engineers equipped it with top-class sensors like an active electronically scanned array, or AESA radar, a passive radio frequency, or RF sensor, and an infrared camera. The active electronically scanned array sensors are a game-changing radar technology that is powerful enough to track even stealthy aircraft without getting caught. Also, the aircraft is fitted with radio frequency, or RF sensors, which activate the aircraft's radio and use it to pick up signals and information without sending out its own signal, making it nigh undetectable to most Hunter aircraft. But for an aircraft that flies at Mach 6, how does it sustainably protect its heat signature from Hunter aircraft with infrared technology completely capable of reading heat signatures, especially from an air beast that big? The fighter is equipped with cooling systems around the avionics to reduce the heat that comes from the surface, keeping potentially large hotspots cool enough to avoid infrared detection. But it gets even better with the specially coated painting in pitch black that not only blends properly into the night sky, but also absorbs, spreads, and dispels the heat that comes from the friction of the aircraft, speeding at 6 times the speed of sound against the air. While its Hunters are perfectly on display, the aircraft is retrofitted with an ASM-3, a supersonic anti-ship missile being developed by Mitsubishi Heavy Industries to replace the ASM-1 and ASM-2 missiles, and also microwave weapons, or direct energy weapons in more popular parlance. Microwave weapons are the next level of fighter jet armament, as they are capable of ranged weapons that damage their targets with highly focused energy without a solid projectile, including lasers, microwaves, particle beams, and even sound beams. While it has not been actively found in use by most top militaries around the world because of its unpredictability, especially when aiming for a smaller and moving target, potential applications of this technology include weapons that target personnel, missiles, vehicles, and optical devices, now in the FX. While the Hunter killer missions are nigh perfectly suited to this aircraft, the Japanese history with war, which includes heavy losses of lives in Hiroshima and Nagasaki, prompted them to find a different solution when this aircraft is in use. Ergo, to reduce losses, they decided on introducing an unmanned combat aerial vehicle that can operate significantly beside the FX. Think of it as a shadow bodyguard that will be called the Combat Support Unmanned Aircraft, which would be responsible for carrying even more sensors and radars, making it easier to spot targets, or more importantly, threats to the pilot's life while he flies the FX. This wingman style is not too dissimilar from the Kratos XQ-58 Valkyrie or Boeing Air Power Teaming System project, where the drone acts as the loyal wingman to the aircraft. While the wingman drone to finally complement the FX is not touted to be available until the 20s, the FX has definitely started to ruffle feathers in Eastern Europe, particularly Russia. Although the Kremlin remains stuck in a loop of asymmetrical warfare, with Ukraine over their decision to join forces with the West and sign up for membership as a part of the North Atlantic Treaty Organization, or NATO, the course of the war could suddenly change when Japan completes the FX project. While it is unclear why Japan might be interested in picking a side in the Russo-Ukrainian war, the United States, which has already picked a side, Ukraine's in the war, holds a lot of sway in Japan, a country where they have military bases and where they are owed some respect because of Pearl Harbor in Article 9 of the post-war Constitution. Ergo, it isn't so hard to infer that they might influence Japan into equipping Ukraine with an FX, changing the landscape of the war completely. Whether Japan decides to support Ukraine with its new fighter jet, adding a new complexion to the war, or simply stays away from the Eastern European forces, remains to be seen.
The United States has constantly been in the limelight for its insane innovations and the development of advanced weapons that the world has never seen before. But now there has been a significant shift that has garnered a lot of attention and raised intrigued eyebrows across several nations. In the Middle East, Japan has become the talk of the town due to its newly developed aircraft, a fighter jet that is worth billions of United States dollars. This development has not only struck fear in the hearts of its enemies, but has shocked the world in general. It has also given rise to questions like, does this new innovation stand as a force to be reckoned with? Why was this aircraft rejected by the United States? Join us as we delve into the intriguing features of the new Japanese aircraft that shocked the whole world. Ever since the development of advanced and sophisticated weapons was deemed important in order to get the upper hand in conflicts, the mantle of technological development has constantly shifted from the United States to China and even Russia. Interestingly, Japan has also made it into the spotlight for the development of its own fighter that features unrivaled capabilities. The question on everyone's mind is, what is this new development? Well, Japan's new fighter jet got its inspiration from the Northrop YF-23, which is equally an advanced fighter jet that is renowned for its unrivaled features. It was first made as a prototype in the Advanced Tactical Fighter program. This program began in the late 90s with the aim of creating a fighter that could perform several roles, be used in different kinds of missions, and replace old but renowned F-15 and F-16 fighter jets. In its quest for a perfect option or inspiration, the top aviation companies all presented their ideas for Japan's new jet. But Northrop's design caught their attention, and they decided to make something similar but even better. This YF-23 aircraft was expected to take the place of the revered F-15 and F-16 jets. It simply means that the YF-23 must surpass them in terms of capabilities, speed, and effectiveness. Let us have a look at some of the features of these old fighters and decide if the YF-23 is really up to the task, or if it's a great inspiration for the Japanese. The General Dynamics F-16 Fighting Falcon is a fast and versatile American fighter plane. It was first made by General Dynamics for the United States Air Force and was designed to be really good at fighting in the air during the day. Over 400 of these planes have been built since 1976. In 1993, General Dynamics sold the part of their company that was in charge of making aircraft to Lockheed Corporation. And after the merger with Martin Marietta in 1995, it successfully became a part of Lockheed Martin. This fighter boasts some really interesting features, like a canopy without a frame, which serves to help the pilot have better vision, a control stick on the side to make the jet easier to maneuver, and a seat that is comfortable and designed to reduce the force on the pilot during quick movement. In addition to the comfortable feature in the cockpit, there is also a special flight control system that makes it very agile. Maintaining its stealth ability, the fighter has 11 different places that can be used to store extra things like weapons and ammunition inside the cannon. Another intriguing specification of the F-16 is that it was made to be less expensive to build and easier to maintain when compared to the older fighters before it. The frame of the jet is made up of special types of metals like aluminum, steel, composites, and titanium. The parts, like the flaps, stabilizer, and fins, use string structures made of bonded aluminum honeycomb and coated with graphite epoxy lamination. Unlike older aircraft, it has fewer points that need lubrication, fuel connections, and parts that might need to be replaced. Interestingly, over 80% of the access panels can be reached without using stands. Despite the original flight hours of this jet being designed to last for over 40 hours and handle 7.33 grams with 80% internal fuel, the developers decided to make its frame last for 8 hours instead and designed it to handle a 9-gram maneuvers with full internal fuel. This decision turned out to be the best when the jet used changed from just air-to-air combat to handling different missions, as the aircraft for more systems and weight along the line. Strengthening programs were needed to keep it strong, efficient, and reliable. F-15. Eagle, on the other hand, is a powerful American fighter jet that is equipped with 2 engines. In 1969, the United States Air Force chose the design after selecting from several. The Eagle, as it is popularly called, took its first flight in July 1972, and it became fully operational in 1976. This aircraft is considered one of the most successful and efficient modern fighters after having more than 100 wins in air combat and no losses recorded. Most of these victories were achieved by the Israeli Air Force. Another unique fact concerning the Eagle is that, even though it was made specially for air battles, it also had features that made it useful for ground attacks. Because of its flexibility, a better version called the F-15 Strike Eagle was created for an all-weather attack from 1989. This version was then sold out to other countries, where the different variants were made over time. The United States Air Force planned to replace all their original air superiority F-15s with the F-22 Raptor by 2010, but unfortunately, they could not get enough of the F-22, so they had to keep using the Strike Eagle II, the FF-15EX, which is planned to remain in service with the U.S. Air Force until the 2030s. Many countries make the F-15, and there are still new and improved versions being developed. It operates on two Pratt and Whitney F-100 with afterburners. The engines are put next to each other in the aircraft's body and get air through rectangular openings with adequate intake ramps. The pilot's seat is high in the front part of the jet, with a big windshield and a large canopy similar to the one found in the F-16. This feature helps the pilot see better. Also, the frame of the plane was made using advanced superplastically formed titanium parts in the 1980s. Are there other features that make the F-15 unique? Absolutely. The jet can make a tight turn without the need to slow down because it has a low weight-to-wind ratio. It can also go up to 30,000 feet in about 60 seconds. When it's flying at a particular speed, the engines can produce more thrust than the weight and the air resistance combined, which allows the jet to fly really fast. The weapons and controls are made so that one person can handle air-to-air combat well. Deviating from the normal design, the A and C models have one seat and are mainly used for air superiority, while the B and D models have a second seat for training. The E model uses the second seat found in the cockpit for someone who's in charge of handling the weapon system. Unlike many other modern fighters, this aircraft does have the typical aerodynamic exhaust pedals covering the engine nozzles. This is because there were problems with them during the development, like coming off during flight so that they would be removed even though it would increase the aerodynamic drag by 3%. The fighter jet once flew with only one wing after an Israeli F-15D had a mid-air collision with an A-4 Skyhawk in 1983 during the Negev mid-air collision. Most of the right wing was gone, but the pilot, Zvi Nadivi, used full afterburner and landed twice as fast as normal at Ramon Air Base, successfully. Wind tunnel tests on a model with one wing showed that controlled flight was possible only within a small speed range and angle of attack. This event led to research on technology that can adapt to damage and a system called Intelligent Flight Control System. Now that we have an idea of what the Japanese aircraft is up against, let's go into the features and design of the aircraft and confirm if it truly surpasses the F-15 and F-16 in terms of capability and advancement. As mentioned earlier, the Japanese aircraft was inspired by the YF-23's development, so it's only normal that we take a look at the features of this jet to get a better picture of what the Japanese Mitsubishi F-3 might be like. The YF-23 fighter was designed with stealth technology as a main idea. The shape of the plane is made in such a way that radar beams bounce away, making it hard to detect. The plane also goes really fast, up to 1,093 miles per hour, and can move really well. It has a unique wing shape called the flowing wing, which helps it not stand out easily. Additionally, it has a super advanced system with some parts using artificial intelligence. The YF-23, also known as DP-117K, is a unique-looking plane. It has diamond-shaped wings, a shape that helped reduce air resistance at high speeds, and a V-shaped tail that could move in all directions. The cockpit was high up, near the front, for the pilot to see well. The jet had 3 wheels for landing, with 1 in the front and 2 at the back. The place where the weapons are kept on the fighter is under the fuselages between the front and back wheels. Also, it is powered by two turbofan engines, each of which can be found in a separate part of the plane's spine with special ducts to protect the engines from radar waves. The front side of the engine has trapezoid inlets with special panels to absorb turbulence and direct it over the winds. Well, there were two YF-23 fighters that were built, and the first one, also referred to as PAV-1, had Pratt & Whitney YF-119 engines, while the second, PAV-2, was powered by General Electric YF-120 engines. The aircraft generally makes use of a single explanation ramp nozzle and doesn't use thrust vectoring like the YF-22. The exhaust from the engines went through troughs with cooled tiles to release heat and make the engine invisible from infrared homing missiles that are positioned below it. Its engines and aerodynamics allow it to fly really fast at a speed of 1.6 without using afterburners. Its computer system controlled how the plane moved in the air. To make the jet roll or tilt to the side, the computer lifted the flaps and ailerons on one side while lowering them on the other. The V-shaped tail fins were tilted at a 50-degree angle from upright. To make the plane go up or down, the computer turned the tail fins in different directions. Turning the tail fins in the same direction made the plane turn sideways. According to test pilot Paul Metz, the fighter jet could handle high angles of attack really well, even up to 60 degrees. If the computer lowered the wing flaps and raised the ailerons on both sides at the same time, it helped slow down the plane in the air. To save money while building the prototype, some parts from other planes like the F-15 and FA-18 were used. With all these features, it should have been the perfect inspiration for any fighter jet. But that didn't happen. This is because Lockheed Martin developed a model of the renowned F-22 Raptor. Both fighters met all the performance requirements. The YF-23 was practically invisible and could be extremely fast, and the Lockheed fighter could undergo tight maneuvers. Despite the technical superiority of the YF-22, the United States selected the F-22 Raptor as their main fighter. However, despite the rejection of this fighter, which possesses intriguing capabilities, one nation worked towards reviving it, making it better than before, and designing it with advanced features that even the United States did not foresee. Let us move on to how Japan came into all of this. At a time when the United States banned the sale of the F-22 Raptor to protect its advanced technology, including its stealth capabilities, Japan was unable to purchase the F-22. This resulted in them thinking about producing their own formidable fighter jet. At the same time, the FX program was initiated, with an estimated value of more than $45 billion. Definitely, building an advanced fighter comes at a price. Making their thoughts materialize, in October 2020, Mitsubishi was awarded the right to develop a new fighter jet. Instead of doing everything from scratch, the developers decided to buy out a project that was rejected by another country. Guess what? It happened that the project was the YF-23, and it was used to create the latest Japanese fighter jet. Let's dive into how Japan transformed this rejected fighter into something that has struck fear and admiration in the hearts of many. The Mitsubishi F-3 is a sixth-generation fighter jet designed to gain air superiority. For this purpose, Japanese experts incorporated the most promising technologies, including the possibility of deploying a combat laser or electromagnetic weapons. This helped to make the aircraft the most dangerous opponent for any enemy. It was created to make the country's defense industry stronger and maybe sell weapons to other countries as Japan changes how it defends itself. In October 2020, Mitsubishi Heavy Industries was chosen to lead the development. The FX is designed to be hard to detect by radar. It has air ducts that twist and an internal weapons bay to reduce its radar reflection. Electromagnetic wave absorbers, made of carbon-based material, are used on air ducts and engines to absorb radar waves, making them harder to spot. tests showed that this could cut the radar detection range in half. The FX also uses metamaterials, made of different materials, to reflect radio waves. These materials are applied to the pulsed Doppler system to control radio wave reflection. To avoid being noticed by radar, the FX mostly relies on passive detection. Its radar emissions are managed to lower the chance of being detected by counter-radar systems. The FX uses plasma stealth antenna technology to change how radio waves bounce off it. This antenna creates temporary plasma with electrical control, making it hard to detect. When activated, the antenna can also send and receive communication signals. The fighter is powered by two XF91 engines with an efficient afterburner thrust of 16,500 kilograms per force. Interestingly, it is twice the thrust of the renowned American F-35. In the early stages of development, they planned on making use of XF9 engines to power up the jet. By 2018, they officially stated that their level for the prototype engine was 11 tons or more in military thrust and 15 tons or more with afterburner. The XF9 engine is designed to be flexible, which allows for different thrust levels depending on the need. The target maximum thrust for the future fighter engine program is 20 tons, which is about 196 kilonewtons or 44,000 pounds per force. The engine has a high combustion temperature of 1,800 degrees Celsius and is slim compared to its power, with the engine inlet being about 30% smaller than the General Electric F-110 that was used in the F-2. The slim design is necessary to accommodate several internal weapons, which in turn improves its stealthy nature. This engine has a substantial electrical power output of 1/8 kilowatts, and this provides a total of 360 kilowatts from both engines. The high input generation is important for powering the fighter's advanced avionics and equipment. The engine also features three-dimensional thrust vector nozzles that allow the aircraft to be very maneuverable and, in turn, enhance its stealth capability. The thrust vector nozzle can deflect thrust up to 20 degrees in all directions. In December 2021, Japan signed an agreement with the United Kingdom to collaborate on developing and designing the sixth-generation engine. The joint efforts involved engine manufacturer Rolls-Royce and IHI. A viability study has been going on, and the Italian manufacturer Avio Aero joined as a partner in the development of the engine. Later on, efforts for the collaboration were set to begin in Japan's next financial year, starting on April 1, 2020. The possibility of equipping the aircraft with engines that have a variable thrust vector is also being considered, and this would make the Japanese fighter super maneuverable. However, the ability to generate 180 kilowatts of electricity to be used for combat laser or electromagnetic weapons is more interesting because it will burn out the enemy's electronics at a distance of up to 8 miles. The fighter also has quick suspension points for tactical weapons, like guided hypersonic missiles or nuclear missiles. In addition to the intriguing features of the fighter, the Mitsubishi F-3 has received heavy-duty onboard equipment. First, the aircraft would be controlled by a technologically advanced interface that would help optimize data flow and simplify piloting and combat missions. The aircraft's body acts not only as a laser antenna, but also generates electronic interference. It also has an ultra-fast system for processing and transmitting data from all surveillance and guidance systems, from powerful ground-based radars to advanced airborne gunners. Now, here's the cherry on the cake. Japan is planning to utilize unmanned combat drones that can work with the F-3. These drones, which are referred to as combat support unmanned aircraft, are quite similar to other projects like the Kratos XQ-58 Valkyrie or the Boeing Air Power Teaming System. In this setup, the drone is meant to act as a helpful partner for the main aircraft. There are two types of drones: the one that carries a sensor and looks for a target, and the one that fires weapons and whose main function is to protect the main fighter from incoming missiles. Both versions would be designed to have the same design. Also, the plan is to have the drones fully developed and operational by 2030. Thanks for watching. While you are still here, click on the link on your screen to check out another of our videos. See you there.